Hi, and welcome back to C Programming Skills using Replit. I'm Norman McIntyre. Let's get started. So here we're going to look at what's called the standard I/O, that is standard input-output functions. So here I am in our standard project, one we're now familiar with, the printf hello world. We see the output here. In this video, we want to learn some new functions. So I'm going to begin by saying put s. Now put s stands for put string. And I want you to notice right here, and you'll get used to this, the environment will display the name of the function as you're typing it in. So in this case, put s, which stands for put string. And the way you read this, it says this is the name of the function, right? Put s is the name of the function. We pass into it what is called a string, and it's constant. Constant means the string does not change. It returns an integer. So when you call a function, you pass something in, it returns something back. And in fact, let's do this several ways so you'll understand what's going on here. First, if I just click on that, notice it positions the information that I need to fill out. So here it's saying, give me a constant character pointer to something called underscore underscore s. Now I realize this early in the course that's confusing, but think of this as you're pointing to a string. All this really is hello world in C. And a string, here we go again, we've talked about this earlier, but a string is something that's human readable. So what put s says is it puts out the string. In fact, when I click on run, we see hello world in C. It's a very subtle point, but notice the difference between saying put s for put string versus printf, which is print formatted. Print formatted actually has many more options, and you have to be more precise about how you format a string. Here, put s, notice it automatically took us to the new line. So if I say put s hello again, it automatically takes us to a new line. As opposed to this one, if I don't put my \n, which is this special character for new line, if I don't put that, let's say I say hello and then print formatted world, and I then say printf \n. We know that \n is a new line character. So I click on run and we see hello world, hello again, hello world. And of course we see that this printed out the hello, it then printed out the world, and then it printed out the \n. Now when I come to this, earlier when I was typing this in, when I said put s and we saw it pop up, this help, we're passing in a string, and again const stands for constant, meaning this is not going to change. You're just going to pass it in, it's going to stay constant. Notice it returns something. I wonder what it returns. It's called an int for integer. So let's do this out of curiosity. Let's say int result. Okay, so we're declaring a variable, a box called result. We're going to put an integer inside of it. And so I can say result equals to put string. So it's going to put this string out, but it's going to put the result in here. In fact, let me just print out hello. And I'm curious, what does this, we know an integer is coming back, but what is it? Well, to find out, let's do the print formatted, and in quotes, let's say result %d. %d is a placeholder for a decimal, \n for a new line. Then I do comma. By the way, notice up here, again, we're getting our help displayed. And what this is saying, print formatted, printf, you pass into it a constant character pointer, Well, that's what we're doing here. This is a constant character pointer, comma, dot, 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 meaning other things can follow this, and what can follow in this case is result. So let's see what this does. One of the best ways to learn coding is just try things, right? Just try and see what happens. Well, let's see what happens here. I click on run, and look at this. It says hello, result is 6. I wonder what 6 is. Well, let's count the characters. 1, 2, 3, 4, 5. 5 characters, but it said the result is 6. Well, remember what this displays. This actually adds a new line character. So when you call put s for put string, it puts out the characters, it adds a new line to it, and when we add all those together, we see we get 1, 2, 3, 4, 5, 6. That's what it returns to us. So it tells us how many characters have been output. Let's do it again. Let's take this variable called result. Here we'll do the put string again, passing in the hello again. Of course, this time we see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then we know there's a new line character, so 12. Well, let's see if that tells us we output 12 characters. Let's give it a try. So click on run. Aha! 12 characters. So this is important. It shows you that as you write code, when you call a function, and these are called functions, pre-written code that you can call, you give it an input, and it does something, and it returns an output. And in fact, later in the course, you'll write custom functions. You'll write your own functions that do this same thing. All right, so we've seen put string. We've seen print formatted. Let's do one more. Let's do fprintf. Wow, fprintf, what's that? Well, I want you to notice this first parameter, which I realize is a little confusing. Anytime you see this star and we're seeing file, it's like, wow, that's something totally new. We'll kind of ignore the details for right now, but this is a file print formatted. And you're thinking, well, you mean you can write to a file with this? We can, and we'll get to that later in the course when we talk about files. However, for right now, I want you to notice this first thing, file, pointer, and they call it a string, which again, don't worry about the details. The key is you can say do a file printf to a predefined file called stdout. In fact, we see it pop up right here, stdout. So do a file printf, and here I'm going to say hello yet again, \n. And the difference, there's actually no difference between this and this, other than we're making it very clear we're going to what's called standard output, and standard output is the console. In fact, let me run this. Hello yet again. And of course, you look at this and you say, well, why would you do this if this does the same thing? Well, here's why. You can do a file printf to standard error. So stderr is standard error. And so I can say hello to, how about we'll say hello to standard, so stderr. How about that? And you know, this one I think I'll say hello to standard out. So standard output to the console. Well, where does standard error go? Let's find out. Let's click on run. Oh wow, standard out and standard error both come to the console. So why would you want to break these up? Well, here's something. Here's why. Sometimes when you run a program, and remember we said you can run your program from the console by saying /main, right, and running it. Let me clear my screen. sometimes when you run it, you want to send the output to a file. Oh, let me call this I'll just call it output.txt. This greater than sign says anything coming to the console, put it into a file. Now, when we did this, I want you to notice when we said redirect the output, we know from previously when we run this normally, we see all of this come to the screen. But this time, when we said the greater than sign, which says redirect the output into this file, the only thing we see come to the screen is standard error. We did not see the standard output. So this is a clever way to send output to a file, except if you have an error. And if you have an error, it will come to the console. Now sometimes people will ask, well, can you do it the other way? Could you have it where you only send error messages? You only send standard out. In other words, over here, could you capture this to a file? It turns out we can. In fact, if we do main, remember we just did this, output.txt. I think I called it output.txt. We just did this. Well, it turns out that is a shorthand for saying send the output to what's called file descriptor 1. A file descriptor is a number, so here 1 to output.txt. So whether you say send the output here or doing it like this, it's the same result. And the reason I wanted to show that is if we say send the output to 2, 2 is, I'll call it stderr.txt. This file descriptor called 2, we're sending the output. And notice the standard output came to the screen, but now when we look at this standard error, when I click on it, look at that. Hello to standard error. So we're able to send the output, the normal output, and the standard error output. We can send them 2 different places, and we can do that by doing the standard out and standard error. So that's pretty cool. Let me do one more, kind of our grand finale. Sometimes people ask, suppose you wanted to send not just the output to a file, the standard output, and not, in other words, send that to a file and send this to a file. How can you do both of those? Well, we can do it like this. Send the output to, let's call it, we'll say output.txt. And then we say send the error to 1. So basically this syntax says take the error output, but how about send it to 1? And we know that 1 is the output here. So when I do this and I press enter, check that out. We had nothing come to the screen, but if I say cat my output.txt, notice we've got the standard error came out as well as the standard out. So they both came out. So very interesting. And by the way, standard error has a higher priority than standard out, and that's why we actually saw, even though we said hello standard error here, it turns out standard error has a higher priority as far as output. It's what's called non-buffered, and it goes right to the screen, whereas this is buffered up. It's kind of a detail you don't have to know right now, but the key thing, the most important thing in this lesson, this video, is know there's a put string, there's a print formatted, and there's a file print formatted. All right, as always, thank you for making it this far. A lot more to come. I'm Norman McIntyre. Thanks as always for watching.